So let's do one more problem, just to make sure we fully understand these, because these are very difficult problems. It's challenging to graph any type of quadratic because you have to do this completing the square so that you can get vertex formula. And there might be other methods that are okay to use, but ultimately this is probably the most straightforward. So I'm going to rewrite this. G of x is minus x squared minus 6x minus 6, and I want to complete the square. So I'm first going to isolate the variable terms, and since the coefficient on x squared isn't 1, I'm going to factor out this negative, or negative 1, from each of these terms. So let's do that. I have minus 1, or just negative, times this parentheses. Here I'm left with x squared, and here I'd have plus 6x. I'll leave a space and put the minus 6 on the outside. Now, to complete the square, remember we have to add a number here to transform this to a perfect square. And the a value from our formula is always half the coefficient on x, so 3 in this case. And the number we have to add is always a squared, so 3 times 3 is 9. So I will add 9 here. Let me change colors. And I'm adding 9 on the inside of the parentheses. So really, this negative would distribute to the 9. So instead of adding 9, I'm actually subtracting 9. And if I'm subtracting 9 here, I'm going to have to add 9 on the outside just to cancel it out. So when I rewrite this as a perfect square, this would be x plus a, and a is 3, squared, and this simplifies to plus 3. So I now know the vertex. That's going to be the x value that makes this expression 0. So that'd be minus 3. And when you put minus 3 in here, this all goes away, and your y value is just 3. So we have the vertex. And let's do the intercepts again, just because that's the most precise method here. So we'll do the y-intercept first, since that's usually the easier one, since that's just when x is 0, which we can just plug that in. So g of 0, when we plug that in, we just get 3 squared, which is 9, and then we want the opposite of that, plus 3, so that'd be minus 6. So we have the point 0, minus 6 as our y-intercept. And let's find the x-intercepts now. So remember the x-intercepts, that's when y is equal to 0. So we'll have to set the whole equation equal to 0, or in other words, g of x we'll have to set equal to 0 since g of x and y are the same. And so we have that 0 is minus x plus 3 squared plus 3. And so solving this, I'm going to add this whole expression to the other side to essentially make it positive, but on the left. So I have x plus 3 squared, and this equals 3. And from here, I can square root each side. So when I do square root, on the left, the square and the square root will cancel, and I'll effectively end up with the absolute value of x plus 3 equals root 3. And from here, with an absolute value equation, you would set it equal to the positive version of this and the negative version of this. But usually, we kind of skip this step in practice and just write that we have x plus 3 without the absolute value bars. So we just assume that the square and the square root cancel, and we write plus or minus root 3 to account for the fact that there are going to be two solutions. So we can subtract 3 from both sides, so x is minus 3 plus or minus root 3. And remember, root 3, I should say, is approximately 1.73, so this is approximately minus 3. Let me rewrite that, that's a bit messy. So we have approximately minus 3 plus or minus 1.73. And so this gives us minus 4.73 when we subtract it. And when we add it, we get minus 1.27. So we have our x-intercepts at minus 4.73, comma 0, and minus 1.27, comma 0. And from this, we now have the vertex in both intercepts, so we can draw a pretty accurate picture. So let me create a coordinate plane so that we can actually draw this. So let's start with our vertex at -3, 3. So that's up here. And then we can do the y-intercept. That's at 0, -6. So 1, 2, 3, 4, 5, 6 right here. And the x-intercepts at -4.73. So that's about right there. And at -1.27, about right there. Now we could also use a fifth point, since we know that our parabola is going to be symmetric about this vertex. So this point over here, notice, which is 3 points away from that x value of the vertex. So if we go 3 points on the other side, that would also have a y value of -6. And from here, let's just connect all the points. And from here, you can see we have a rough approximation of what the graph would look like. So with all of these intercepts, we have a pretty accurate picture. Without the intercepts, as you saw in the last example, you have to guess a little bit, and so it's not perfect. But as always, if you have a computer drawing this, then it will draw it perfectly.